In this lesson, we're going to be talking about the properties of numbers. And there's 4 properties in particular that we're going to talk about. All of the slides after this one are going to be places where we're just going to identify which of these 4 properties is being applied. So let's get started and go through them. The first one is called the commutative property. Our definition reads, the order in which you add or multiply numbers can switch. And in our examples, you see we have 2 plus 3 equals 3 plus 2. We also have for multiplication 4 times 3 equals 3 times 4. Now we're going to need to memorize these names and be able to select them. So a nice trick I like to use for the commutative property has to do with the first portion of that first word, commute. You may have heard someone talk about their morning or afternoon commute to and from work, or you may have taken a commuter train at some point. Both of those instances of the word commute basically mean to travel from one place to another. And that's exactly what our numbers are doing. The number 2 travels from the left side, from the left of the 3, to the right of the 3. Or we can say that the 3 travels from the right of the 4 to the left of the 4. It's commuting commutative property. Our next one is the associative property. Our definition reads, the combination that you group addition or multiplication with parentheses can be switched. For example, 2 plus 3 plus 5. According to our order of operations, the 3 plus 5 should happen first. 3 plus 5 is 8, plus 2 is 10. But we can regroup it, 2 plus 3 in parentheses plus 5. Do the parentheses first, 2 plus 3 is 5, plus another 5, still 10. And the same thing applies for multiplication. If we do 6 times 7 before we do times 4, or we do 4 times 6 before we do times 7, you're going to get the same result then as well. Now, an easy way to remember this one is the beginning of this word, associate. For instance, I can say, oh, I like to associate with this friend over here because we like a lot of the same movies. And I don't associate with that person over there because we don't have a lot in common. And you can change who you associate with based on your interests, maybe where you live, things like that. But what's happening here is our numbers are reassociating who they are with. In the first example of multiplication, the 6 and the 7 are associated together. In this one, the 4 and the 6 associate together. And that's the associative property. The next one is the identity property. It says by adding 0 to a number does not affect the sum, and multiplying by 1 does not affect the product. Example, 2 plus 0 is 2. 3 times 1 is 3. The identity property, and it's all about the word identity. You keep your identity. You never change who you are. 2, when you add 0, remains 2. It kept its identity. 3, when you multiply it by 1, still 3. It gets to keep its identity. Right. And then the last one is the distributive property. To multiply a value outside parentheses to all values inside the parentheses. So here we have 3 times 2 plus 5. We would do the 2 plus 5 first, which is 10, times 3 is 30. Or we can distribute that 3 so that we have 3 times 2, which is 6, and 3 times 5, which is 15. and 15 plus 6 would be 30. Another easy way to remember that one is the word distribute. Perhaps maybe you've heard the saying about, if you're going to have gum in class, did you bring enough for everyone? Well, in that case, you would be being asked to distribute that gum to every person in the class. Or if you go to a party and you're passing around slices of cake, you're distributing the cake to every person at the party. And that's where the word distributive comes in, distribute, and that's how you can remember that property. So let's look at a few examples. In our first one, we're saying 3 times 1 equals 3. We started with 3, we multiplied it by something, and it remained the number 3. Which property is that? That's right. It's an identity property. Because the number 3 kept its identity. Let's take a look at this next one. 5 plus 4 equals 4 plus 5. Which property is that? What did the numbers do? They moved. They changed places. They commuted from one place to another. This is an example of the commutative property. Ooh, this one has a variable in it. Let's see what happens. We're saying that x plus 0 equals x. Well, we started with x. We did something to it, but it stayed x. This is another instance of our identity. Let's take a look at a few more. Name which property. We're saying that 2 times 3 plus 9 equals 2 times 3 plus 2 times 9. We applied the times 2 to each number that's inside the parentheses. We distributed it. And that's the one that we're doing. This is the distributive property. For B, let's take a look there. We have 7 plus 3 plus 10 equals 7 plus 3 plus 10. What changed from one to the other? The parentheses changed. And what did the parentheses do? They group things together or cause the numbers to associate with each other differently. This is the associative property. Let's take a look at this last one. Looks a lot like B, doesn't it? It's got 3 things and there's parentheses. Wonder which one's going to happen. We have 8 plus 9 plus 2. 9 plus 12, excuse me. And here we have 8 plus 12 plus 9. What changed? Did the parentheses move this time? No, they didn't. Even though it looks a lot like an associative property demonstration, that's not what happened. What really changed? The change is right here. The 12 and the 9 switched places. They moved from one place to another. They commuted. This is an example of our commutative property. So now let's use our properties to simplify this expression. We're going to use the properties to simplify 18 plus 21 plus 12. Now, what this is really meant for is what you're going to do inside your head. So this is a bit of mental math here. I'm going to show you everything on the screen, and it's going to look actually more complicated than the problem already looks. So we're just adding three numbers together. But after I've gotten it all down on the page, I'll walk us through it again so you can see what we're really going to do really fast inside our own heads, which, remember, our brain is still the fastest computer around, faster than anything else you can get a hold of. So let's look at this. Let's begin with the number 18. I can split that up to become 10 plus 8. The number 21 can be split up to be 20 plus 1. And I can split the number 12 into 10 plus 2. Now this is all addition. There's no negative numbers. And because of that, we can apply both the associative property and the commutative property, which means all 6 of these numbers can move anywhere in this expression, and we can regroup all 6 of these numbers with new parentheses. So the first thing I wanted to bring to your attention is this: 8 and 2. Well, we know what 8 and 2 is. You should recognize that pretty quickly, because 8 and 2 are just combining together to make 10. And that's what we're going to do, is we're going to group the 8 and the 2 together. I move the 8 to the beginning, put the 2 next using the commutative property, and then regrouped them using parentheses. Now let's go through our bigger numbers. I have 10 and another 10. So plus 10, plus 10. I've got a 20, plus 20, and the only thing remaining is a 1. So what do we have? We have 8 plus 2 is 10, plus 10 is 20, plus 10 is 30, plus 20 is 50, plus 1 is 51. And maybe you're thinking, wow, we took 3 numbers, turned it into 6 numbers to get our answer. Wouldn't it have been easier to just add them together? And if we're doing it on paper, like we just did here, or writing it out, yeah, you're probably right. It would be easier to just add them together vertically. First do 18 plus 21, get your answer, and then add 12. But like I said at the beginning of this slide, this is an instance of when we are really looking to do mental math. And the moment you see that there's an 8 and a 2, you can be thinking, I can group that to make 10. So in the tens place, I have 1, 2, 3, 4. The 8 and the 2 make 5, or 50. And then I have the 1, 51. That went kind of quick, didn't it? You can see all the real math that happened here as I did it quickly in my head, which is the whole point of what we're doing here. And let's finish up by doing that same thing again one more time, but this time using multiplication. 2 times 8 times 25. Here's what we're going to do. We're going to do 2, leave that one alone, times 8. I'm going to leave that one alone, but I'm going to split up that 25 into 5 times 5. This is all multiplication. We have 4 numbers. We can apply commutative and associative properties. And I see a 10. Do you see the 10? 2 times one of these 5s is going to be 10. So I'm going to regroup those together. 2 times 5. And then I'm going to regroup together the other remaining numbers. 8 times 5. So I've used the commutative property to rearrange my numbers and the associative property to add some parentheses. Let's do this really quick. 2 times 5, we already said, is 10. 8 times 5, that's 2 single-digit numbers. We remember that from our times tables. 8 times 5 is 40. And 40 times 10 is 400. Writing it all out, yeah, it looks like I did a lot of unnecessary work. But remember, the point is mental math. 2 times 8, 16. 16 times 25. Are you really going to do that in your head? I'm not pleased about the idea. I mean, you could, but it would take forever. So we split up the 25. 2 times 5 is 10. 8 times 5 is 40. 10 times 40, 400. Problem's done, and we did it in our heads. And that concludes our lesson on the properties of numbers.